science talk. Why? Because we have always feel very pride and proud about our research scientists who have come over here from National Chemical Laboratory, Pune, and present he is working as a director for that at the Bangalore. Hats off to our Dr. B.L.V. Prasad Garu. He is the Telugu person, moreover Vijayawada person, Satyanarayanapuram Nevasi. Hats off. Such a great personality we have from our Vijayawada Satyanarayanapuram. He is the pride and proud of our Vijayawada, Krishna Jilla, Andhra Pradesh, having the lot of elevation across the globe, not only in India. He is a proved extraordinary speaker, scientist regarding to all chemical related matters, nanotechnology and all. Sir has visited not only our Indian universities, Indian colleges like our K.B.N college, he has visited Japan, all main universities, main educational institutions, USA, America, UK, France, Germany, wherever he goes, he hoisted the flag of Vijayawada, Satyanarayan, AP, especially Telugu people, pride and proud. So there we have to feel very happy. So really, I felt very happy. Such a great people we have in Vijayawada also, such a great personalities we have as a Telugu person. So, Sir is going to demonstrate all science related matters. Already Madam has told. I think we have very extraordinary K.B.N stalwarts students from MSc Organic Chemistry and Analytical Chemistry also. Hats up to all the MSc students who have attended here, and also we have BSc students from CBZ, Chemistry, Computers, MPC. So you are all, already I told you, you are the diamonds, Kohinoor diamonds of K.B.N college. Being a K.B.N college product, wherever you go after completion of your degree or post-graduation, you have to hoist the flag of K.B.N college like our dear sir B.L.V. Prasad Garu. Why? Because he is hoisting our state flag across the globe. That should be there in our mind. You have to take him as a role model. Now I request our beloved Dr. B.L.V. Prasad Garu to start the program and give the valuable advices and valuable upcomings whatever we have in scientific fields across the globe. So you should be familiar, my dear student friends, and feel it is your interactive session. Sir is going to tell whatever doubts you have, you please interact. Sir is having a lot of depth in all related matters. May I now invite Dr. B.L.V. Prasad Garu, sir, please start your session. Please give him a big round of applause, my dear MS and PhD students who have come over here. Thank you very much, sir, for coming to our great institution, which is having 6,000 plus students. Ours is the biggest college, quality-wise, quantity-wise in Krishna University area. Out of 168 colleges, we have a lot of medals and prizes, sir, across the India. Thank you very much, sir, for coming here. Thank you very much once again. Please be a part of our K.B.N college whenever we need your presence. Please be in touch with us. Definitely, we never forget you, sir. Thank you very much. Please.
Hello. You could get. Okay. Good afternoon. If we can remove this, if it's not needed. This is an afternoon session, right? Very difficult, isn't it? So my job, my efforts and the challenge that I have is not to allow you to sleep, right? It's very difficult. So I have done this talk in 2 sessions. I was told that there are BSc students, there are also MSc students. So I have to kind of build up the story, right? I will build up the story. First of all, introduce you to what is nano, right? And then tell you what are the recent advances in nano. And finally end up with some career opportunities for science students. It need not be for nano science and nanotechnology alone. But before starting, let me first of all thank you all for having me here. I also thank all the faculty members. I know they are all very busy in the academic council meeting, board of studies meeting. Despite that, I always enjoy coming to K.B.N college. The hospitality is fantastic, right? Kohinoor Diamonds of K.B.N college. Thank you very much for having me here. I thank Sri Bhagya Kumar Garu, Krishnaveni Garu, and of course Principal Sri Narayan Rao Garu, and my close friend, Dr. Kapagandu Lakshmanan, right? Yeah, Ramakrishna. I admire your father, sir. His father was my teacher, anyway. So thanks to all of you for having me here. So not to allow you to sleep, my job will be to interact with you. Right? I will be asking questions. Will you answer? Right? What is the latest movie that is getting released this week? Sir. Okay. How is sir? Okay. Blockbuster or flop? Average. She says average. Okay. She is not at all happy with sir. Okay. I don't know whether she will be happy with this sir or not. Okay. Let me see that. Okay. Anyway, so I have titled my talk, the first part of my talk as nano, what, why, and how. Right? I will try to relate to you. Right? And as I said, I will start asking questions. But before that, before starting a movie, you have to see some advertisements, right? Okay, Mukesh Alavnadu, right? You have to see that, right? Okay, let us see how Mukesh is doing. Huh? Okay, so this is the place I belong to. I belong to 2 laboratories right now. One is National Chemical Laboratory, which is in Pune. The other one is called Center for Nano and Software Sciences, where I have moved about 2 years ago as a director. This lab is a very famous lab, almost 60, 70 years old now. 73 years old, so very soon going to be 75. So probably you will all know about this laboratory. Otherwise, it is a CSIR laboratory, one of the premier laboratories of CSIR system. This laboratory, which is called Center for Nano and Software Sciences, in short CENS, is a relatively new laboratory. It is also started in 1991, but it is establishing itself. I will tell you why. Of course, both of them belong to this Minister of Science and Technology, Government of India, right? It's not that we are from different organizations in that sense. So to introduce SENSE to you, Center for Nano and Software Sciences, it was established in 1991 by a person called Sivaramakrishna Chandrasekhar. Okay? He is a nephew, Manaludu, right? He is a nephew of Sir C.V. Raman. You all know C.V. Raman, right? Okay? So Aina Chellal Koduku, right? So he is also a very well established scientist, Sivaramakrishna Chandrasekhar. There are 2 S. Chandrasekhar. One is Subramanya Chandrasekhar. How many of you know him? Subramanya Chandrasekhar. Another S. Chandrasekhar. He is also related to C.V. Raman. Ayana Tambudi Koduku. C.V. Raman Tambudi Koduku, Subramanya Chandrasekhar. C.V. Raman Chellelu Koduku, Sivaramakrishna Chandrasekhar. Under family, under scientists. Okay? Right? So, Subramanya Chandrasekhar is a person who is an astrophysicist. He is a Nobel laureate by himself. Okay? He is a person who has found this Chandrasekhar limit, black holes. Right? So, this is that Subramanya Chandrasekhar and this is Sivaramakrishna Chandrasekhar. He is also a fellow of Royal Society. Right? And then he started a lab called Center for Liquid Crystal Research. How many of you have heard what are liquid crystals? Anybody knows what are liquid crystals? Anybody knows or heard the term LCD? LCD? What is LCD? Liquid crystal display. Right? A display that uses liquid crystals, and you are using, whenever you are using a digital watch, any screen that is showing, right, without the LED lights, but it is showing, the black and white. Earlier you must have seen the clocks or whatever it is, they are all using liquid crystals, a molecule, a class of molecules called liquid crystals. Okay, he is a pioneer. He started the field of liquid crystal research in the world. Right, he found a phase of liquid crystals called discotic liquid crystals. It's not that they make disco dance, right? They are disc-shaped molecules, right? Disc-shaped molecules, and therefore they are called discotic liquid crystals. I think you are blocking some of their views. I don't know whether we can, all of you are blocking probably their view, right? I don't know how to block, Anyway, so we moved on, and this is a new laboratory that we belong to, and this particular person is Professor C.N. Rao, Bharat Ratna C.N. Rao, who is inaugurating the laboratory. Okay, and we are at this place called Arkavati campus. We call it as Arkavati campus. Anybody who is interested in visiting a laboratory, please do visit us. We do organize laboratory visits, and you are welcome to visit our laboratory. Okay, so we have these beautiful facilities, and who is interested in research or doing what is called an internship, especially the MSc students, please write to us or visit this site called crf.sense.res.in. CRF stands for Central Research Facility. Central Research Facility. You look for that and then and obviously these are the areas of research that undergo in this laboratory, especially this particular field called soft matter or liquid crystals. It's a very unique field. Not many laboratories in the country, right? There are not many laboratories who are doing research in this field of research, in this area, right? So this is a very unique field, and it is the only laboratory that is doing research. What are the uses of doing this research? So let me show you that. Are you seeing this video in the middle? Are you seeing this video? You can see that this particular glass right now, to block light, you have actually put curtains everywhere, right? Okay, so you can see that, I don't know whether you are able to see, there is a curtain here which is basically being operated by a remote, and this is nothing but a liquid crystal, basically a liquid. Okay, so which, if it is flowing into the glass or in between two sandwiched glasses, the glass becomes transparent. If the liquid is not there, because there is a refractive index matching. If it is operating, then it becomes transparent. If the liquid is not operating, then the glass is opaque. Let me play the video again. Right? No more cloth curtains needed. Right? And by just a remote control, you can basically raise the curtain or down the curtain. And no more gold, whatever, what is the good night. Right? Machar yahan pe hai. Right? Machar is behind the curtain. Right? Right? This is very useful. This is absolutely fantastic area of research. Okay? So I am telling you is this. There are problems associated with our surroundings, right? If you look at this particular classroom, there are several things that can be made better, right? And research basically is coming out of these problems. You need to identify what are those problems and how do we provide solutions, right? And if we provide that, another example of that is this mask. Obviously, many people tribo, right? Why is tribo? Triboelectricity. Have you heard of this term, triboelectricity? Anytime during the winter, I don't know Vijayawada enta untundo gaani, but baga chali pradeshallo, if you go and touch a door knob, right, you get static electricity, right? When you get shock, sudden shock, it is due to static electricity. So between any two dielectric materials, if you rub them, మీకు చిన్నప్పుడు ఎక్స్పెరిమెంట్ చెప్పుకుంటారు కదా, దువ్వెన తోటి బాగా రుద్దుకుని పేపర్లు పట్టుకోండి, right? That's all static electricity, right? So can we generate static electricity? And if we generate static electricity much below the whatever, మనకి షాక్ తగలకుండా static electricity create చేస్తే వైరస్ ఏమవుతుంది? Right? That's what the research we did, and then we found that virus actually gets, see generally what is the other way of filtering virus? Virus comes, it cannot pass through, right? But the virus is there on your cloth. If you touch it or something happens, if you sneeze, maybe that virus goes out and then it sticks to some other person. What we thought is, can we actually repel the virus? For repelling the virus, what we should do? We should create charges, because virus is a charged particle. Whatever it is actually a charged particle. It's a negatively charged particle. So can we repel? Two negative charges. You create negative charges on your mask, and there is a negative charge on the virus, they get repelled. So there is no sticking of virus to your cloth mask, right? And this was actually picked up, and this was actually available in the market, right? That's basically what is beauty about research, right? You can think of a problem, provide a solution, and the product comes into the market, nothing like that, right? So let us stop the right advertisements, Mukesh advertisements now. Carbon private, Mukesh, everything gone. Let us move to what is nano, right? How many of you recognize this movie clip? I am a big movie buff. మన విజయవాడ ఉన్నప్పుడు సినిమా చూడబోతాను, right? శుక్రవారం, శనివారం, ఆదివారం సినిమా చూడవచ్చు మనకు కోసం, right? So సినిమా ద్వారా I will tell you what is nano today, right? So what is this movie clip and what is the character saying? Anybody can say that? Somebody said. Who is saying what? Unfortunately, the audio might not come. Is there an audio jack that you can connect? No, right? Okay. Wonderful. She is great. Give her a big clap. Enduku, emiti, ela. Right? Nano, what, why, and how? Let us understand that. Right? So, first of all, emiti. Right? What is this nano all about? As I said, unfortunately, the audio clips are not coming through, but it would have been much fun if it also comes out. Let us understand this, right? So these three questions are extremely important. Though this is funny, but these questions are extremely important, right? Why, what, and how? Let us understand that. So when we are saying nano, right? Which nano are we talking about? Right? I will be using what is called a Feynman technique. Feynman is a very famous physicist, right? He told that let us not try to give lot of equations, etc., when you are giving a talk. What he said is, give them analogies, right? Whatever you have seen in the real life, మన రోజు చూసే లైఫ్ లో ఏవైతే అనాలిసిస్ ఉంటాయో వాటి ద్వారా you try to tell science, right? And I try to do that. Maybe I am not as great as Feynman, but still let me try that, right? Simplify your explanations and create analogies, right? That's what I will be trying to do. Okay. So as I said, in the which nano we should be worried about, right? There are three examples there. You are seeing something. I am sorry, this is not very clear. This is called nano edge. A screen called nano edge. This obviously all of you know. Nano card, and there is a nano SIM here. Okay. If not these two, I am sure you are all familiar with this, right? Everybody has a nano SIM only, right? Okay. ఇంతకంటే పచ్చి మోసం కొట్టేది. Nano SIM కంటే పచ్చి మోసం కొట్టేది. If you see these three SIMs, the SIM size has not changed. Extra plastic ఒకటే కట్ చేశారు. ఓకే. వాడు నానో సిమ్ అని చెప్పి మన దగ్గర 100 రూపాయలు. ఓకే, నేను అనుకోండి ఇంకా మాట, ఎందుకంటే పబ్లిక్ లో ఉన్నది కాదు, రైట్? సో కావాలంటే మీరు ఇది కొనుక్కొని సూపర్గా కత్తెరతో కట్ చేసుకోవచ్చు. ఇట్ వర్క్స్ ద సేమ్, రైట్? వీ హ్యావ్ టు బి లిటిల్ స్కిల్ఫుల్, రైట్? సిమ్ని కట్ చేయడం అంతే, రైట్? సో బట్ నానో సెల్స్, నానో అనగానే మనం కొనుక్కుంటాం. వై? What are the reasons that we are at least little bit of addiction to this nano? Lightweight, okay? So extra weight, correct? Okay. Small in size, right? Nano, one of the meaning, or the exact word meaning is nano means small, right? So these are all. This is the thinnest screen. This is the smallest car in the segment, right? And this is the smallest thing right now available, right? So that is why one of the meanings of nano is basically, nano is in Greek means dwarf, and which means small, right? But nano also, why should they put something else, smallest they could put, no? Why are they putting nano? Why is it become a selling point? Nano also tells you that it is superior, right? In its performance, it is better, right? This is also becoming a selling point. Whenever something you put a nano, before that, we have started as a consumer, we have started accepting it as a superior technology, right? So they are selling that, or they are basically kind of exploiting that kind of a thing in our mind. That nano means superior. Okay, so when it is small, this is for general meaning, English meaning, right? When it comes to science, all of us are science students, right? Okay, so when it comes to science, for us nano means something else. What is that something else for us, nano? Sir, Vire? So I will be picking up someone randomly, right? Don't worry about me. This question paper answer. Okay? But you are picked up is important. That means you are showing attention. Right? Okay. So what is that something else nano means? Small size is English, right? But for science, what is the other meaning? Anyone else? Small. Now I want a scientific. What is in science? What does it mean? Yes, madam. I am not able to hear.
Something is becoming
New, okay. I want a scientific, right? What do you mean in science by nano? A prefix, nano. Again, I gave a clue. Nano means 10 power minus 9, right? That is actually, so thank you. So, nano means 10 power minus 9. Okay. How many of you are physical chemistry students here? Physical chemistry? Some physical chemistry? ఎక్కడ చదవలేదు అలా వదిలేశారు గాలికి ఛాయిస్లో వదిలేశారు మేము వదిలేసినట్టు రైట్ సో ఫిజికల్ కెమిస్ట్రీ టీచర్ దగ్గరికి వెళ్ళి ఏదైనా చెప్పంగానే సార్ నేను స్పీడ్ గురించి చెప్తాను ఏదో అడుగుతారు సంథింగ్ ఓకేనా నేను అక్కడి నుంచి ఇక్కడికి రావడానికి గంట పట్టింది నా సైకిల్ ఏమో 10 గంటకి వాట్ ఎవర్ నేను 10 కిలోమీటర్ల వేగంతో నడుస్తుంది డిస్టెన్స్ ఎంతో ఏదో అడుగుతారు ఒక నెంబర్ చెప్పాం 5 అంటాం 5 వాట్ రైట్ దేర్ షుడ్ బి యూనిట్ నెక్స్ట్ టు దట్ రైట్ For any number, you need to have a unit. Okay. Now, when we are talking about nanoscience and nanotechnology, what is the unit that we are referring to? Nanometer, right? Now, you can have a problem. The teacher okay? Why? Why is it that you are only interested in nanometer? Why is it that you are? What are the other 2 units, sir? No, అది లెంత్ లో CGS యూనిట్స్ చెప్పండి 3 CGS అంటే ఏంటి సెంటీమీటర్స్ గ్రామ్ సెకండ్ రైట్ దట్ ఇస్ CGS రైట్ 3 fundamental units time weight and length right these are our fundamental units right anything you have to convert these 2 units only these 3 units only right so now the question is why are we not interested in a meter. Sorry, why are we only interested in a meter and why are we not interested in a second or why are we not interested in a gram? Why is it the nanogram is not so important? Why is it the nanosecond is not so important? Why are we so obsessed with nanometer only? Have you ever asked this question? Why is that when we call nanoscience and technology, you are only talking about devices or materials which are in the size of nanometer, but we are not basically not related to nanosecond or nanogram. There is a very interesting thing about this. I have spent a couple of minutes on this because this is extremely important. As you all said very well now, nano means 10 power minus 9, right? On a scale, nano means 10 power minus 9. Do you know this scale? 10 power minus 3 is milli. 10 power minus 6 is 10 power minus 9 is 10 power minus 12 is 10 power minus 15 is 10 power minus 18 is I think front నుంచి వస్తుంది ఎందుకంటే అక్కడ చూస్తున్నారు ఓకే 10 power minus 18 is ఆటో 10 power minus 21 is జెప్టో నేను అలాగే పక్కన చెప్పేశాను ఓకే I asked 10 power minus 18 10 power minus 18 is ఆటో 10 power minus 21 is జెప్టో 10 power minus 25 is యోక్టో రైట్ సో ఇన్ని స్కేల్స్ ఉంటే నానో అని నానోమీటర్ అని వీటిని ఎందుకు పడుకు వెళ్ళాడుతున్నాం right this is an extremely important thing to understand So let us see that. Okay. Obviously, we are interested in nanometer only, and like why is that we are not interested in nanosecond, or why is that we are not interested in nanogram? Right. Let us worry about that, and then I will tell you why are we interested in only nanometer. Okay. So a nanosecond. You can MSc students organic chemistry MSc students. సిగ్గుపడుతుంది దీనికి ఏదైనా మ్యాట్రిమోనీలో నువ్వు రిజిస్టర్ చేసుకున్నావని అడిగాను ఏంటా రైట్ ఓకే సో మీ అందరికి ఆర్గానిక్ కెమిస్ట్రీ కదా మీరందరూ మోస్ట్లీ ఓకే సో లెట్ మీ ఆస్క్ యూ క్వశ్చన్ CH3 with a dot what is it called which radical CH3 with a dot methyl radical right I have two methyl radicals two CH3 dots I brought them together and asked them to make a bond. By the way, chemistry is nothing but bond making and bond breaking, nothing else, right? So I asked them to make a bond. How much time does it take for two methyl radicals to come together and make a bond? When everything else is favorable, all other conditions are favorable, I am asking two methyl radicals to come and join. How much time do you think it will take? 1 day, 1 minute, 1 second? Fraction of second. Which fraction? Right? There are which fractions, right? Okay, I will give you the answer. It is a femtosecond. 1 femtosecond it takes for a carbon-carbon bond to form between two radicals. Okay. Now, if one carbon-carbon bond takes only a femtosecond to make, each carbon can make how many bonds? Each carbon can make 4 bonds. Now you can calculate actually how many bonds it can form in 1 nanosecond. 1 femtosecond lo oka bond form. Oka carbon 4 bonds form chestundi. Okay, so alaga adi catenation avutundi kabatti it can replicate itself, right? So if it can replicate itself in 1 actually nanosecond, it actually makes these many number of bonds. 4 into 3 power 10 power 6 minus 1. A minus 1 anadi first bond కోసం. Right? So this is a staggering number. ఈ నెంబర్ కి లేదు మేబీ సంస్కృత్ లో ఉంటుందేమో కానీ మిగతా వాటిలో మనం చెప్పలేము ఓకే అంత పెద్ద నెంబర్ రైట్ we cannot even write that number if I ask you to start writing that number it will take at least this day so big number so the molecule formed after these many seconds in 1 nanosecond is so big it will fill this room it will really fill the room by the volume itself. So the molecule formed by 1 nanosecond will not display any unique properties. We were interested in nanomaterials and nanoscience and technology because it was also showing some interesting properties, right? So this material will not show any interesting properties. Therefore, a reaction that undergoes for a nanosecond is such a long reaction. It is not a short reaction, it is a very long reaction. In other words, a nanosecond is a very long, right? It's very long in a time scale, not a short one. So మీరందరూ నన్ను చూస్తున్నారు కదా నాతో మాట్లాడుతున్నారు నా మాటలు వింటున్నారు నన్ను చూస్తున్నారు సో మీరు నన్ను చూస్తున్నప్పుడు the reaction that happens do you know what is the first reaction that happens in your eye? There is a cis trans isomerization of a rhodopsin protein, right? There is cis trans isomerization. This cis trans isomerization also happens in 1 femtosecond. ఇంతకంటే ఎక్కువ అయితే right? Even if it is 10 femtoseconds మొత్తం ఒక్క రోజులో అనుకుంటారో నాకు in driving, right? Because your reflexes have to be so fast that it has to be a femtosecond, right? So therefore, in time scale, nano is not small. Where is femto? 10 power minus 15. 10 power minus 15 is 6 orders of magnitude smaller than nano, right? 10 power minus 15, 10 power minus 9, 6 orders of magnitude smaller. Right? Let us go to the weight scale quickly, and here is a favorite question of mine, and then I am hoping that co-linear diagrams will answer me. Right? I have very carefully listened to me. 18, everybody, including the BSc students, can answer this. Okay? So 18 nanoliters of water. I have 18 nanoliters of water. How many molecules of water are there? At least you tell me how to calculate this, I will be very happy. Somebody raise your hand, or you are just stopping your 18 nanoliters of, why is it 18? Why did I ask 18 nanograms? When you say 18 nanograms, 18 grams of water will contain how many molecules? 18 grams. 1 mole of molecule will contain how many molecules? Come on. 6.023 into 10 power 23. But how that number? అన్ని మనకు తెలుసు. ఇలా రిలేట్ చేయడమే తెలియదు. రైట్? 1 mole అంటే వెంటనే చెప్పేసి కదా. నేను ఇలా డంక తిరిగి అడిగాను కదా. మరి ఎప్పుడు ముక్కు అంటే ఇలా అడిగాను. రైట్? Therefore you could not. It is 1 mole of water, but I am asking not 1 mole but 18 kind of nanomoles of water, right? So which means that it will have 10 power 14 molecules. 10 power 14 molecules. Is 10 power 14 small number? Right? The droplet size will be somewhere around micron or something like that, right? It's a big droplet. And water will behave normal like water. It will not behave anything different. Therefore, again in weight scale or volume scale, nano is not small. Nano is not small in weight scale or volume scale. Right? Therefore, if you want to really have 100 molecules of water, by the way, 100 molecules of water తో మీరు ఒక డ్రాప్లెట్ కనుక తయారు చేస్తే it will actually flow upwards. Due to capillary reaction, it will actually flow upwards, not downwards. Right? Very interesting things happen. Its dielectric constant is completely different. Everything is different. 100 molecules of water కావాలి ఉంటాయి మీ దగ్గర ఒక డ్రాప్లెట్ లో 100 molecules of water ఉంటాయి ఆ డ్రాప్లెట్ వాల్యూమ్ ఎంత ఉంటుందో తెలుసా జస్ట్ 100 molecules of water ఆ వాటర్ డ్రాప్లెట్ మీరు క్యాల్కులేట్ చేయొచ్చు యాక్చువల్లీ బై జస్ట్ టేకింగ్ దిస్ dimensions volume density you can actually calculate but let me give you the answer the water droplet molecule the size of the molecule will be the droplet will be jectoliters it will be a jectoliter 10 power minus 21 again it is 12 orders of magnitude smaller than nano, right? So nano by no means is smaller in time scale, nano by no means is smaller in volume or weight scale, right? Only in length scale something very important happens or something very interesting. That is why nanometer is extremely important. What is one order of magnitude smaller than nano in length scale? One order of magnitude smaller. 10 power minus 9 meters is nanometer. What is 10 power minus 10 meters? There is a very beautiful name to that. It is a scientist name. 10 power minus 10 meters. ఒక ఏ రాసి దాని మీద ఏదైనా సున్నా పెడతాం రైట్ Angstroms. All our atoms, molecules, all the dimensions that we talk in the laboratory, in chemistry, is angstroms. Right? So therefore, one order of magnitude, you can go to picometers, but what will you get? An electron or a proton, you cannot hold it. An ion you can hold, and the ion size is basically magical point on the length scale. Nano is a magical point on the length scale. It is not a magical point on the time scale. It is not a magical point on the weight scale or volume scale. Right? So it is a very important thing, but I hope you understand. Lot of interesting things happen, right? One of the things that happens when you make objects of nanoscale is basically what is called specific surface area increase. Means the number of atoms on the surface becomes larger as compared to the bulk, the number of atoms that are present in the bulk. Right? Why are we worried about that? Right? You know, so let me take the example of sorry. So ఈ row తీసుకున్నామంటే right there are two people who are on the bulk and three people in the bulk right in the center and two people on the surface right so we did that if you make bonds you can make bonds with your either hand can you make bonds with your either hand when you have a nanoscale objects you have more number of atoms on the surface as compared to the bulk and therefore they are very reactive right and that is one of the ways of measuring that is what is called specific 1 gram of material you can actually cover entire football field the specific surface area of 1 gram of a nanomaterial is so high that you can cover entire football field with just 1 gram of material that's so high area right that is extremely important for catalytic applications we were discussing with back in the morning how many number of atoms are there on the surface what is the percentage surface of atoms you can all take this when if you are interested I can talk to you more on that okay so another interesting thing is melting points change of the material when it goes to nanomaterial like మనం lab లో వెళ్ళగానే ఏదైనా మెటీరియల్ recrystallize benzoic acid recrystallization I don't know how many have you done benzoic acid recrystallization అయిపోగానే melting point measure చేయాలి melting point correct గా 1 or 2 నే ఎంత వస్తే will report చేయాలి so now you can say that no I made a nanomaterial of benzoic acid and therefore it is not showing the melting point that is it's supposed to do right? Melting points change of the and can be ever heavier material by just changing the size of the material, right? This can happen at nanoscale, right? And there are a lot of other, optical properties of materials change, right? Some of the materials that are there in this are gold and silver. You see solutions there, you don't see gold and silver, and they display beautiful colors. This is all due to what is called surface plasmon resonance, right? So don't worry about all these things. Just accept the fact that when you make a material of the size of nanometer, the material, the properties it is otherwise showing, it displays completely different properties, completely unique properties. Whenever something there are unique properties, these materials will have lot of applications, right? New properties, new applications, right? That is why we are interested in all of them. So these are again emitting properties. This is again this quantum dots called basically 2-4 semiconductors, 3-5 walk on water. అలాంటి షూస్ మనకు కూడా ఉంటుంది సార్, రైట్? విజయవాడ కావాలి మీద నడుచుకునేట్టు, రైట్? నో బ్రిడ్జెస్ needed. This is all due to a phenomenon called superhydrophobic effect, right? So superhydrophobic effect, there are two phenomena. One is called a Cassie-Baxter state. This is lotus, right? Where the water droplet is running off, and this is where the water droplet is stuck to the surface, but it is still a droplet form, right? So we have created in our laboratory a similar phenomenon. You can see, I don't know how many of you can see on the glass plate now, my student is putting a droplet with a coated surface, right? Underneath there is no coating. You can see how water droplet is spreading. Here it is not spreading, it is like a droplet, right? So what is the use of this technology, or if you make material, what is the use of this material? Where will it be useful? Any daily life phenomenon where you can use this? Right. Waterproof jackets, yes. There is a beautiful application, yes. Any other thing? Umbrella, okay. What is it? Car windshields. Have you seen car windshields? ఎవరైనా డ్రైవ్ చేస్తున్నప్పుడు ఒకసారి మిస్ట్ వచ్చిందంటే ఎంత దారుణంగా ఉంటుంది కదా. It causes a lot of accidents, right? You can prevent all that, right? You have to have a transparent glass, but water should not be sticking to it, right? So you can create all that using here. Another very interesting application, which is again in our daily life, is basically non-stick tawa. How many have you seen non-stick tawa? మనం అందరూ సౌత్ ఇండియన్స్ దోశలు అంటే కానీ అట్లా అంటే కానీ చాలా ఇష్టంగా ఉంటుంది, రైట్? ఆ పెన మీద దోశ వేస్తాం, కాసేపు అయిన తర్వాత అది అంటుకుంటుంది, అప్పుడు ఇక మొదలెడతాం, రైట్? తవ్వడం, ఆ తవ్వడంతో ఏమో వస్తాయో తెలియదు మనం. So there is a Teflon body. If you can create a non-stick tawa without Teflon, by this hierarchical structures that are present on your non-stick tawa, beautiful, right? And in fact, మనం ఇలా కూర్చున్నాము, there is a project that is approved by US, right? I am not faking you, right? So somebody is doing that kind of a technology, preparing non-stick tawa, non-stick frying pan out of basically superhydrophobic effect, right? This is another interesting example. So few more examples and we take the first plate, right? I think I have time up to 4:15 or so, right? Okay ma'am, మనం ఆపేద్దామా? సినిమా బాగుందా బాలేదా? బాగుంది, కరెక్ట్.
సరే అన్న, ఒకసారి 360
జాగ్రత్తగా చూడండి. వాట్ ఇస్ హ్యాపెనింగ్?
రెడీ పెట్టండి సార్. రైట్ సార్, ఇలా
What just happened? You want to see it again? Right, one more time. మన ఫేవరెట్ హీరో కదా.
ఇప్పుడు మారింది కదా అన్న, రైల్వే ఉందా? అదేంటి అని నెట్ స్లోగా ఉన్నాడు.
By the way, who is that hero? Who is that hero?
ఎందుకు పెట్టి సెట్టింగ్స్ వస్తున్నారు సరే.
అమ్మ విజయకాంత్ ఒక్కదానికి ఏమేస్తారమ్మా? ముందర అండి, కెప్టెన్ విజయకాంత్. You have to say Captain Vijayakanth, right? Okay, he is a Tamil actor, hero called Vijayakanth. It looks silly, right? So somebody said bulletproof vest or bulletproof jacket. Bulletproof jacket is not supposed to reflect your bullet back. It is supposed to just block the bullet. Here what is happening? The bullet is reflected and poor fellow whoever has fired the bullet, he has got killed. Right? ఇలాంటి బుల్లెట్ ప్రూఫ్ జాకెట్లు ఉంటాయి కనుక మనం జాగ్రత్త, రైట్? ఓకే, ఎక్కడికైనా వెళ్ళిపోగలం. right? So, but in the city ga undedi, this has to, I am not saying that this movie has inspired, but there is a great research going on whether we can create similar materials, right? And I will show you now real, right? No VFX, no RRR, no nothing, right? So normal, real, laboratory movies.
ఆహా రేం రావాలా
Pay attention again.
పెట్టిన రావాలా ఇంటూ
So there is a bullet that is fired, and what happened here?
క్యామ్ రొటేషన్
A hole got created, right? This is a nylon cloth, whatever we are wearing. Some of us are wearing
Front
nylon
camera.
cloths,
Front
or cotton
camera
cloths, or whatever it is. So now I am firing a bullet. It's not in my lab, some other lab in US. Sorry. What happened? There is no hole, there is a mark, but the bullet has gone back. Have you noticed that?
ఆఫ్ చేసాము
Right? So this is possible. The reason is that a bullet pierces the cloth not because it is very sharp, etc., but it's projectile, whatever the velocity, whatever the force that it has, is such a high velocity. So the cloth has to withstand that force. So the cloth has to recoil, go back, and then push it back. Right? This is what it has to do. And for that, what you need to do is put some nano materials between the fabric, so that the fabric is not snapping off. In the fabric snap off. So it has to go back and pull it, push it again, right? So this is very important. Lightweight, like right now, I'm sure all of you know our army, like in Kargil, very high elevated places, very cold. They have to wear such a very heavy bulletproof vest. They are very heavy. చాలా మంది మీలో లైక్ హెల్మెట్ పెట్టుకోమంటే పెట్టుకోరు కదా, చాలా మంది ఆల్మోస్ట్ హెల్మెట్ పెట్టుకోరు, ఏదో నేనా నేనే పెట్టుకుంటాను కాబట్టి రైట్. ఎక్కడ ఉన్నారంట ఫ్రెండ్ లేదా? ఓకే, నువ్వు పెట్టుకోదా కదా, బైక్ లేదా? ఓకే, బైక్ ఉంటే పెట్టుకుంటావా? లేదు, సరే లేదు. ఓకే రైట్, మనకి లైఫ్ గా ఇంపార్టెంట్ ఇదే. Right? So the reason is that it is not, no, we understand the reason. The reason is that it is heavy, doesn't allow breathability. So now if you can make lightweight breathable helmets, again a beautiful project that is going on in many DRDO. Lightweight breathable, right? Where air can go on in and come out, right? Such kind of material you can create, this will be very useful. The other example I want to add, this is very dear to my heart, because I was part of some of this project. So I am very, very happy about it. So I am sure you must have heard, including Mana Vijayawada Kuda, COVID time, though, I think it is Swarna Hotel, Swarna Palace, or somewhere, there was a fire during COVID time in ICU departments where the patients are not supposed to even get up their bed. Alaanti chotla fire vaste vaalaki veldtaru. And what is the reason for that fire? Mainly this cloth. Right? Bed linen antaru. Mana bed మీద వేసేవి, లేదా curtains, whatever it is, they are all, highly fire catchable kind of a material. Basically, material, avasaram. Right? You make that and there is a fire, how difficult it is. I will show you two examples of it. This is normal cloth. You can see what is happening here. Jack, పెట్టారండి ఒకసారి మనం చూద్దామా, ట్రై చేద్దాం ఒక్క 2 minutes. ఓకే, టెక్నికల్ బ్రేక్. అదే you can see how the cloth is catching fire. Now you put nanoparticles into that, into the same fabric. If we can bring this to our cloth industry, etc. Okay? So 2 or 3 more slides, we'll take the first break, right? Okay. So how did it all start? In nanotechnology, how did it all start, right? Somebody should have started it, right? Okay. I'm sure if he is there, even in our ancient texts, there are this Ayurveda Bhasma, all those things. So there are things that are known about material showing unique properties when it is made small. Materials display unique properties when it is made into small sized object, right? So one of the well-known examples of such thing is a cup called Lycurgus cup, which is made in 400 AD. Ivananta, you are dated 2023 somewhere February, right? Okay. So this is 400, 1600 years ago. 1600 years ago, somebody made these beautiful cups. It's not an exact date, but during that period, people knew how to make what are called stained glasses. These are called stained glasses. A glass that is showing color. Right? The interesting thing is, you two cups, it's actually one cup. Right? The difference is that whether you are seeing the cup through what is called the reflected light. When you are shining the light on the cup and the light is coming back, that is reflected light. So if you are seeing the reflected light, the cup will look green. If you see transmitted light, a cup local light petti, if you allow the light pass through the glass, that is a transmitted light, right? If you see through the transmitted light, then it appears pink, right? And people knew how to make these glasses. Up to 400 years, 1600 years ago, people knew how to make these glasses, right? But nobody knew how this color is coming. They know how to make it, but they did not know why this color is coming, right? So one of the persons that asked this question, why this color is coming, is a person named Michael Faraday. How many of you have heard Michael Faraday? Right? Faraday laws, right? By the way, he never knew mathematics. I hope you know about Faraday. He only passed the 8th standard. Right? I did not even pass 8th standard. ఒక బుక్ బైండింగ్ కంపెనీలో పనిచేస్తూ ఆ బుక్ బైండింగ్ కంపెనీలో వచ్చిన పుస్తకం అంతా చదివేసి హంఫ్రీ డేవి అయిన ఆయనకి లెటర్ రాసి ఆయన ల్యాబ్లో గ్లాస్ వాషర్ కింద పనిచేస్తూ అంటే బేసిక్గా అడ్డు తోమేవాడిగా పనిచేస్తూ అక్కడ నేర్చుకున్నాడు కెమిస్ట్రీ. రైట్? అండ్ హీ నెవర్ యూజ్డ్ ఎనీ ఈక్వేషన్ టు ఎక్స్ప్లెయిన్ ఎనీ ఫినామినా. Right? So like anyway, so he asked the question, why is this glass colored? Right? So he went to, maybe I am constructing the story, ila jariguntundani nenu anukuntunna. So he went to the glass maker and asked him, what are you doing? He said, I am taking borosilicate, which is the silicate reduction reaction. So what he did is, he took some metal salts and mainly gold chloride and basically added a reducing agent. A reducing agent. What is it? Red phosphorus. He added a reducing agent, red phosphorus, and immediately he saw the color of gold solution changing from yellow, gold chloride, which is again gold is in +3 oxidation state, Au +3. So that changes to Au0, and that change is basically shown like this pink color that you are seeing in the the transmitted light, right? So he immediately called them finely divided metals. So what happened? So first thing was phenomenon of Lycurgus cup was 400 years, and then he asked the question and showed that it is possible in 1857. It took 1457 years, right? So 1857 is what varaku 200 more years, and then we have made so much progress. So the first question is extremely important, right? Until that time, so many people came, no? So many other scientists also would have come, but nobody asked this question, why? ఎందుకు ఏమిటి ఎలా? రైట్? దిస్ ఇస్ అ సింపుల్ క్వశ్చన్. మనకు నవ్వుస్తుంది, బట్ if somebody asked ఎందుకు ఏమిటి ఎలా, and then he asked the question, he constructed a scenario. ఇలా అయి ఉండొచ్చు. They are taking a metal salt, they are heating it, they are cooling it. Only thing that can happen to the metal salt while heating and cooling can be a reduction, because no metal salt can undergo an oxidation. So let me do a reduction on a metal salt and let me see what happens. And this is what exactly happened, right? So, and then the development of nanotechnology over the last 200 years or so, it's not even 200 years, right? It's somewhere around 70 years, since 1857. So, whatever happened is happened in this period, and then there are two methods of preparation. I'll come back to that. Let me wind up with a small break. I'll come back to that. There is something called top down. There is another thing called bottom up approach, right? Top down approach is basically you take a material and make it smaller and smaller and smaller, right? So how many of you, old time, how many of you seen Keragali? In Hindi it is called chakki piecing, right? So you take a material, pour it into it, and then grind it, and it becomes small. So take a bulk material, grind it, it can become small. This is one way of preparation of nanomaterial. The other one is chemist's way of making nanomaterial. You take smaller than nano. And what is smaller than nano? We just talked about it. What is smaller than nano? Angstrom. You take angstrom sized objects, assemble them, bring them together. They become nanoscale objects. And that's it. Right? Let me show you how easy it is to make a nanomaterial. Right? So, this is again a small video. There is no audio for this, so you can just see what is happening in the video. The gold salt is taken, like Faraday did. Some dilution is happening. It is extremely important. Diluting this solution is extremely important. Thank you. So sodium chloride is nothing but a reducing agent, very commonly available reducing agent in the laboratory. That is being added. Just see the color change here. It is almost that pinkish color, right? So this is how easy you can make nanomaterials in a laboratory. Just take a salt, any metal salt. The example of gold being shown because it is easy to see the color. Otherwise it will be black. Most of the other nanoparticles of other metals will be black in color. Black will be and then we try to make gold particles because they show this beautiful pink color. So you just take gold salt, dilute it, add some water, and add a reducing agent, and then that's it, right? So if it is so simple and so old, ఇప్పుడు నన్ను పిలిచి నానో టెక్నాలజీ మీద మాట్లాడమంటే ఎందుకు కదా? నేను ఇక్కడి నుంచి బెంగళూరు నుంచి తెప్పించి మిమ్మల్ని అందరినీ ఇక్కడ కూర్చోబెట్టి నానా హింస పెట్టి why should we talk about it? కదా? Right? Let us take a break. Next చెప్తాను కథ పెరుగు చెప్పాడు. You can also take a break, relax, 5 minutes, okay? If you have some questions, I will be happy to answer during this time, okay? ఈ కప్ప అయిపోదా చెప్పు అన్నాడు కదా అదే ఈ స్టోరీ వినేశారా? నానా పార్టికల్స్ గురించి వినేశారా? ఇలాగే వినేశారా మొత్తం? అది వేరేగా ఉందా? సో నువ్వు బేసిక్గా గోల్మాల్ 1 చూసావు, లేక F2 చూసావు. ఎక్కడ సార్ చూడలేదుగా? చూపిస్తాను నేను.
అదేంటి డిన్నర్ అయిపోయిందా లంచ్?
ఏమా నువ్వేం చూసావు?
ఇక్కడ వచ్చి కూర్చోవచ్చు కదా
నువ్వు బాహుబలి 1 చూసావా? KGF 1 చూసావా? KGF 1 చూసావా? KGF
సార్ జస్ట్ కూర్చోవచ్చు కదా సార్. సరే ఇంకోళ్ళు అన్నారు, ఇంకోళ్ళు ఎవరు? కిరణ్. మరి ఇక్కడ ఎవరో ఉన్నారు కదా సార్, అది సార్ ఒక్కరిని వచ్చేసారు. ఓ వెనకాల ఉన్నారా సార్? అక్కడ ఎక్కడ కనిపించట్లా? కార్తిక్ సార్. మీరు ఎక్కడ ఉన్నారు? సరే సార్ వెళ్ళే ఉన్నారా లేరా అని చేసి
Shall we start? Another 45 minutes. I was told at 4 o'clock we have to close. Then I thought many more first show right? Okay, అంతమందికి బుకింగ్ ఉన్నాయి ఇవాళ. Right? 5:30, 6 o'clock show. INOX, whatever it is, right? Here you are doing a lot of things. మా టైంలో అయితే సినిమా టికెట్ల కోసం నించుని చక్కలు తిరిగిపోయి డబ్బులు వెనక్కి రాక బోల్డ్ ఆనందంగా ఉంటుంది. Anyway, so what I am going to talk in the next few minutes is about recent advances, right? So I will try to again make it as relatable to you as possible, right? I could have actually titled this talk "Designed and Tailor-Made Nanoparticles," right? So, but then I title better అనుకోండి. అనగానే మీ టీచర్ అందరూ వీడియో బాబు అక్కడ నుంచి చూపిస్తే టైలర్ అంటాడు, డిజైనర్ అంటాడు, వీడి
సార్
రైట్ అందుకే రైట్. బట్ ఐ హ్యావ్ టు టెల్ యూ ది థాట్ ప్రాసెస్ దట్ అండర్గోస్ when somebody is teaching a dress and the thought process that undergoes in the mind of a scientist is exactly the same. The thought process has to be the same, right? When you go to the tailor, what will happen? The tailor first of all will take measurements. నా మెజర్మెంట్స్ ఏం చేసి నీకు పుట్టాడు కదా, ఓకే, అది ఎక్కడికి రైట్. సో యూ కెనాట్ డూ దట్. యూ హ్యావ్ టు టేక్ ద మెజర్మెంట్ ఫర్ హూమ్. ఎవరి కోసం ఈ డ్రెస్ కుడుతున్నామో అది తెలుసుకోవాలి, రైట్. మెజర్మెంట్ ఇస్ ఎక్స్ట్రీమ్లీ ఇంపార్టెంట్. దెన్ అకేషన్, ఐ విల్ కమ్ బ్యాక్ టు దట్. ఓకే, నీకు పుట్టినరోజా, పెళ్ళా, ఉత్తమా, ఏంటి, రైట్, వాట్ ఆర్ యూ గోయింగ్ ఫర్, రైట్. సో హీ హ్యాస్ టు ఫైండ్ దట్ అకేషన్. దెన్ డిజైన్. మన మనిషికి చిరిగిపోయిన జీన్స్ కావాలి, ఇక్కడ అంతా చిరిగిపోయింది మొత్తం, రైట్, ఏముండకూడదు, రైట్. అంటే వాడు చింపాలి, కుట్టి చింపాలి, ఇదో దరిద్రం మనకి, రైట్. ఓకే, సో ఎనీవే బికాస్ ఇవన్నీ చేయాలి. లేకపోతే ఈవిడేమో అనార్కలి అంటుంది, కాపరా అంటుంది, ఏముంటుందమ్మా ఇంకా, రైట్. అండ్ వాట్ ఎవర్ ఇట్ ఈస్, రైట్. ఇక్కడ డిజైనర్ అంటుంది, వెనకాల ఇలా ఉంటుంది, ముగ్గురు ఇలా ఉండాలంటుంది, రైట్. ఇవే పొడుగా ఉండాలి, ఇవే పొట్టిగా ఉండాలంటుంది, నానా రకాలు, రైట్. నాకు ఇద్దరు అమ్మాయిలు ఉన్నారు, డోంట్ వరీ, నేను ఐ నో వాట్ ఆల్ గోస్ ఇన్ దిస్, రైట్. సో ఇట్ ఈస్ ఎక్స్ట్రీమ్లీ ఇంపార్టెంట్. నేను వాట్ ఇస్ ద డిజైన్ అంటే అల్టిమేట్లీ మీ నాన్న కుట్టించగలరా లేదా నీకు, రైట్. ఇవన్నీ చెప్పిన తర్వాత మనీష్ మల్హోత్రా, సబ్యసాచి సర్కార్, వీళ్ళ పేర్లు విన్నారా మీరు? ఓకే, ఇప్పుడు ఎవరు ఈ మధ్య ఎవరైనా ఇద్దరికి పెళ్ళైంది? కియారా అద్వానీ, వాళ్ళ డ్రెస్సులు చూసావు నువ్వు, రైట్. ఏమనుకుంటారు తెలీదా, రైట్. సో వాళ్ళ దగ్గర కుట్టించుకోవాలంటే మన వల్ల కాదు, రైట్, మనం వారి కోసం. So we cannot do that. So we have to see affordability. Similarly, when you go to a scientist, he has to right now think of, he or she has to right now think of what is called sustainability. Whether a material is available, the abundance of the material is extremely important these days, right? So you cannot make a new technology out of a material that is not sustainable. That is extremely important. The second is, what is the application? Enduk kavali? What is the material that you are making? What is its properties? How they should behave? You should know that, right? The third thing is again, that material has to have a design. I will come back to that. What is this material design? I will come back to that. And finally, of course, affordability, right? Any technology, unless it is affordable, it will not be picked up by people, right? So you have to make the technology also affordable, right? So right now we have thought about it. This particular slide is a summary of my previous talk, right? Nano sizing causes changes in, when you change the composition of state to state, shape, size and interparticle distances and supported confinement, you will have color change, conductivity change, melting point change, light absorption change, crystal shape change, magnetism, chemical reactivity, all these things change, right? Therefore there are beautiful properties that are displayed by these materials. Okay, we have talked about that. And then we have also seen these optical properties displayed by particles such as gold and silver, right, based on the size and composition. So that was similar examples that I have shown. With all these new properties of the materials by reduced dimensionality, when I am saying reduced dimensionality, what you are doing is basically decreasing the size of the material to a nanometer scale. That is basically called reduced dimensionality, right? So when you do that, you will have beautiful applications and see the diversity of the applications. The nanomaterials have applications in various fields. That is why it is called platform technology. It is applicable in many fields. I will come back to that. Very interesting thing is cosmetics, right? So whatever the sunscreens that we apply nowadays, or the toothpaste that you have, all of them are having nanomaterials these days, right? So toothpaste or like Savlon, even put a nanotechnology on it, nano silver, right? Like Savlon, Dettol, they are saying nano silver, right? So antibacterial effect. So cosmetics nunchi basically like the energy, nanobiotechnology, drug delivery, so many diverse applications nanomaterials are finding applications in, right? Okay, and I have already told you about two approaches, top down and bottom up approach, and I also told you that we follow the bottom up approaches, right? Now I will show you two more videos related to two diverse applications of nanomaterials, right? Okay, one of them is about what is called printed electronics, right? Printed electronics. Right now, whatever cell phones that you have, all the electronics that are made by what is called lithography, photolithography or electron lithography, right? So there is an electron beam that is writing. Basically, there are integrated circuits in your basically SIMs or whatever it is. These are made by electron lithography. But this is becoming very expensive, and also the feature size cannot be reduced beyond what is available today. If you can reduce lesser than that, you can pack more power into your mobile phones, etc. Right? So you can have terabytes of information available. So if you want to have that, you need to go to different technology. And what is that different technology that is projected for future applications is printed electronics. It is faster, cheaper, and much smaller feature size can be written on that. And for printed electronics,
Nano Dimension has developed a revolutionary solution for electronics professionals that combine our unique award-winning 3D inkjet technology, 3D software, and high-performance nanomaterials. This unbeatable combination has gained recognition and praise from some of the world's leading companies. Our Dragonfly 2020 3D printer is capable of depositing both electrically conductive and insulated materials, enabling designers and engineers to print fully functional electronics in-house in one print job. Companies are already using this multi-material solution to bring speed and efficiency to their development and manufacturing processes, reduce lead times and cost, and create opportunities for design innovation. It's a new revolution. Just like 3D printing has earned its position as one of the most exciting technologies to come to market in the last decade, 3D printing electronics is the next giant leap forward.
right? So this is nanomaterials combined with 3D printing and screen printing. Printing, right? It is not lithography. It is not writing with an electron beam. It is basically printing. Screen printing right? So these are screen printing. So this can be used at a nanoscale now, right? So you can make the possibilities are limitless basically, right? You have seen some of them. So let us take the other extreme. Basically, this is about nanobiotechnology. I was told that some
Here you see the cancer cells growing in a culture dish in the laboratory. For most drugs to be active, they must go inside the cancer cell. Scientists are developing tiny particles, nanoparticles, that can be loaded with drugs. The nanoparticles can be modified so that they attach to the cancer cell and get carried inside. To make sure that the drug-loaded nanoparticles only attack the disease cells, they are engineered so that they only bind to the target cancer cells and not to neighbouring healthy cells. Once they bind to the cancer cell, they are taken into the cell. They can't pass through the surface. Instead, part of the cell surface forms a pit and then it engulfs the nanoparticle. Now we are looking inside the cell. Cellular proteins wrap around the vesicle and drive it inside the cell. You can now see a vesicle carrying the nanoparticle moving towards the very centre of the cell. The vesicle carrying the nanoparticle travels further inside the cell and then fuses with a compartment called an endosome. This is part of the digestive system of the cell's stomach. The inside is acidic, and its job is to digest incoming material. The nanoparticles are degraded inside the endosome, releasing the drug into the cell. The drug can then kill the cancer cell. Nanoparticle-based drug delivery provides a way of attacking cancer without the side effects of conventional chemotherapy.
Right? So what we have seen, a drug being delivered selectively to a cancerous cell and not to a normal cell. Use of nanotechnology. Right? So screen printing electronics, nanobiotechnology or cancer drug delivery. These are two different applications, both based on nanomaterials. Right? And we have seen that nanomaterials can be made very simple. Right? Simple. This video, I don't have to play it again, right? You just take some solution, add some reducing agent, you can make nanomaterials. Can these be immediately used for an application? What is the problem? Why are we not seeing them in an application right now? What are the problems? what I have not told you so far, right? So that's what I am going to tell you in the next couple of minutes. These nanomaterials, if you see them under what is called a transmission electron microscope, they look like this, right? Small dots, right? Somewhere around 20 nanometers in the scale bar here. So each particle is about 20 nanometers. They are well separated from each other. Each is a sphere. Because you are seeing a two-dimensional image of a sphere, if you see a shadow of a sphere, of football, it looks like a disc, right? So this is a disc that is being shown, right? A particle seen like a disc. So these are the particles that are made. We have made the nanoparticles. Can we use them for electronics or drug applications? What are the requirements? What is the designing that is required for them to be used for an application? The requirements of nanoparticles to be used for printed electronics or drug delivery applications are the following. For printed electronics, these nanoparticles should be dispersed in non-polar organic solvents, benzene, hexane, right? Oils, basically. Whereas for drug delivery applications, these nanoparticles should be dispersed in water. You cannot bring benzene, right? Before the drug can act, benzene will kill. So you cannot use that. So therefore you have to put them in water. But the interesting thing is whether they are dispersed in non-polar solvents or polar solvents like water, they should not undergo aggregation. In both the cases, this is a very stringent requirement. Absolutely required. You cannot avoid, you cannot by forego this, you cannot circumvent this. Right? You need to have this condition fulfilled. Not a sufficient condition, it is a necessary condition. Right? So now this is the problem. You made the nanoparticles, right? But whatever you try to do on them, right? So simple to make the nanoparticles. But now you try to kind of disturb them a little bit, add something else to them. Whatever you try to do, they will undergo what is called an irreversible aggregation. And what is the requirement, necessary condition? They should not undergo any aggregation. Whereas here you can see that these nanoparticles are well separated from each other, right? You need to touch it. This is called aggregation. First aggregation. Separate dispersion. Right? So you need to separate them. Right? These are all colloidal aggregation. Colloidal aggregation, daily life, colloidal aggregation. You all do it, most of them. If you go in the kitchen, you will do it, right? Did you make paneer or cheese from milk? Milk is a colloid, right? Can't paneer and cheese can't share a danger. Why happen? Boil is the co-host. Much experience, right? So, right? Okay, నిమ్మకాయ పెట్టాలి, సాల్ట్ వేయాలి. నేను నాకు తెలుసు, నువ్వే వరి అవ్వదు. వీళ్ళందరూ నవ్వుతున్నారు కానీ మనం చేయాలి. ఇట్లా చెప్తారు. వాళ్ళకి చెప్పాలి. Right? Okay, so you add salt or you add basically citrus. Right? So it basically curdles or breaks. మన తెలుగులో మనం పాలు విరిగిపోయినాయి. Right? So ఒక్కసారి విరిగిపోయిన పాలు నుంచి మళ్ళీ పాలు తయారు చేయగలరా? ఎవరికైనా తయారు చేస్తాను. Impossible, right? So this actually the same phenomenon. This is basically like a dispersion. This is basically curdling or aggregation. This is an irreversible phenomenon, right? So this is the problem. So you basically made nanoparticles which actually like a newborn baby. కొత్తగా పుట్టిన బిడ్డ పాప, రైట్? కొత్తగా పుట్టిన పాప ఇలాగే ఉంటారు, మనందరూ ఇలాగే ఉన్నాం. ఎవరైనా డ్రెస్ వేసుకుని రైట్ క్యాపెట్ ఉంటారంటే చెప్పండి, రైట్? ఐ వాంట్ టు సీ దట్ పర్సన్, రైట్? కమ్ అండ్ మీట్ మీ, ఐ వాంట్ టు నో హూ ఆర్ యూ, రైట్? సో వెంటనే whenever a newborn baby is kind of coming out of mother's womb, what will you do? Right? Will you go out? Right? Bahubali. Right? This. Or you will basically protect the baby. Right? Ikkada evaru Ramkrishna leru anukuntaru kada? Right? Sivagami leru ga? Right? So you have to protect the baby, right? Because so far the baby has been protected. Inside amma kattulo chakkaga undi baby. Right? Sudden ga bayati chesi environment ki expose chesam. Ikkada bacteria undi, temperature variations unnai, anni rakalu unnai. Environmental pollution ఉంది, అన్ని ఉన్నాయి. So you have to protect them, almost like a newborn baby, but you cannot handle them the way you are handling other materials. So you have to protect them. These people realize, and then like the people, of course, ఆ తర్వాత ఆ ప్రొటెక్షన్ యొక్క నేచర్ వేరే అయిపోతుంది. like మనం ఏం చేస్తున్నామో దాన్ని బట్టి ఆ ప్రొటెక్షన్ నేచర్ వేరే, రైట్? So basically like not, it also depends on what we want to do. Right? Whether we want to be stupid or silly or like we want to be, right? We dangerous, not a Right? I don't know. Okay. whatever he wants to do, right? So there are crazy people around the world, right? So immediately are like basically occasion, like no, so like no, ఇక్కడ ఉన్న వాళ్ళు ఎవరో ఒకటి, right? ఇది చాలా సీరియస్ వచ్చింది. ఓకే, ఈ మ్యాచింగ్ చేయాలి సార్ మీరు. మీకు వెళ్ళేదా ఎట్లా తెలిసిందయ్యా బాబు? నేను చెప్తున్నాను ఇది పర్ఫెక్ట్, రైట్? వెళ్ళిన తర్వాత జరిగేది అదే రోజు, రైట్? అబ్సల్యూట్లీ చాలా ఎక్స్పీరియన్స్ ఉంది, రైట్? ఆల్మోస్ట్ 30%. Anyway, so jokes apart, right? So there is an occasion. This is what is I am telling, the design. If there is an application, here there is a function. A person doing a function. Your nanoparticles also have to perform a function. If they have to perform a function, you have to create an appropriate design on the surface, right? Let us see how to create that particular surface. So as soon as this nanomaterial research 1857 Faraday cheyagane, 1951 lo inkoka Turkey cheyagane cheyagane, so people realized that this is not sufficient, right? And people were looking how to protect these nanoparticles from undergoing irreversible aggregation, right? And the thing they did is, why don't we protect them? Protect them with a layer of organic molecules. Most of the nanoparticles are inorganic in this, metal oxides, metal sulfides, all kinds of things, right? Can we protect them with a layer of organic molecules? And what are those organic molecules that you can use? These are called alkyl amines, alkane thiols, carboxylic acids. In your prepare, alkane thiol means a sulfur group with a H, right? RSH. R and CH2, 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 CH3. I will show you something like that, right? R like a primary amine, RNH2, right? RCOH, carboxylic acid. So these are the functional groups that can be attached to a metal surface, because metal likes to bond to these functional groups. So you can create what is called an inorganic organic hybrid structure. And this organic group protects the nanoparticles from undergoing irreversible aggregation. Why is that? There is something called steric repulsion. మీ చుట్టూరు ఒక సిలిండర్ పెట్టేశారు అనుకోండి, రైట్? మిమ్మల్ని దాంట్లో వచ్చేసి, రైట్? ఆ సిలిండర్ పెట్టేసి మిమ్మల్ని పక్కవాడిని పట్టుకోరా అంటే సిలిండర్ లోంచి పట్టుకోలేదు, రైట్? సో డబ్బాలో పెట్టేసి. So basically you create a protection around you so that you don't undergo aggregation. So you basically create that. This is the protection, like a spring on the surface, right? When two nanoparticles come together, they cannot come beyond some point. There is a huge force that they have to undergo after they go some kind of a steric repulsion. So these kinds of functional groups are known to be created, and when they are attached to a nanoparticle, you can see that this X group can be an H2SH or carboxylic acid. It is bound to the nanoparticle surface, and CH2, 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 these are CH2, 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 CH3, these are exposed to the solvent. You put them in a solvent, right? So you can basically create what is called a disperser. Now, if this end group is CH2, CH3, which is a hydrophobic group, these nanoparticles are dispersible in non-polar solvents, right? If this is a hydrophobic group, these are dispersible in a non-polar solvent. So now we can create by this, this is basically an entire reaction I have shown. I did not take you through, right? You basically do a reaction, create what are called monolayer protected nanoparticles. When the monolayer is an organic molecule, right? You create this monolayer protected nanoparticles. These nanoparticles can be precipitated and redispersed. It's almost like making milk out of honey now, right? You can precipitate like a powder and redisperse. How many of you have seen antibiotics being given like a powder to you? They give you a powder, right? Azithromycin or like whatever, like, so they give you a powder and go back, go add water, shake it, and then it becomes a dispersion. Right? This is basically what it is being done now, right? You can actually create milk out of powder now, right? So whatever, so that is what you can do that. So these are monolayer protected nanoparticles that you can prepare, and these nanoparticles can be used for your printed electronics applications, right? This is done. Now we can use these nanoparticles because they are dispersible and do not undergo aggregation in non-polar solvents. You can use them for printed electronics applications. So how about protective applications? Because now they are capped with a non-polar organic molecule, which is only dispersible in non-polar solvents like benzene and hexane. They cannot be used for drug delivery applications. How to change that? Right? This is like you can create a dress for summer, but the same dress cannot be used for winter, right? Otherwise, what is that? Right? So you cannot do that. You have to create an appropriate drug for an appropriate season or for an appropriate function. So, how do you do that? I told you, this is the group that is deciding whether the nanoparticles are dispersible in non-polar solvent or polar solvent. Right now, these are dispersible in non-polar solvent because this is CH2, CH2, CH3. Can I change that? If I change that to a sugar group or an SO3 group or a COH group or an NH3 group, then these become dispersible in water, polar solvents. Right? They can be used for using drug delivery applications. Right? So that is what we are doing in our laboratories nowadays, creating all kinds of polar molecules that can be used to protect a nanoparticle and make dispersants of nanomaterials in water. And so that they can be used for bio applications. I will quickly wind it up now. So we in our group use a particular group of molecules called sophorolipids. Right? What are these molecules? There is a COH group which can go and bind to a nanoparticle surface, and there is a sugar which can be soluble in water. Right? So this combination of these two in groups in one particular molecule. Why is this called sophorolipid? This dimeric glucose is a sophorose. What are sugars named as? How are they? What are the names of sugars? Some sugar names: fructose, galactose, maltose, all O's, right? So this is a sophorose. A sophorose attached to a lipid is a sophorolipid, right? So this is a oleic acid sophorolipid. Oleic acid very nara. Have you heard the names Mufa and Kufa advertisements lo? Hey, sunflower oil, right? Rice bran oil. వీటిలో చాలా పూఫాలు ఉన్నాయి, చాలా మూఫాలు ఉన్నాయి. పూఫా ఇస్ మోనో అన్సాచురేటెడ్ ఫ్యాటీ యాసిడ్. పూఫా ఇస్ పాలీ అన్సాచురేటెడ్ ఫ్యాటీ యాసిడ్. ఓలిక్ యాసిడ్ ఇస్ ఎ మోనో అన్సాచురేటెడ్ ఫ్యాటీ యాసిడ్. అడ్వర్టైజ్మెంట్స్ కూడా వినండి, చాలా సైన్స్ ఉంది దాంట్లో, రైట్? ఓకే, సో దిస్ ఇస్ ఎ మూఫా, మోనో అన్సాచురేటెడ్ ఫ్యాటీ యాసిడ్. ఓలిక్ యాసిడ్. పాలీ అన్సాచురేటెడ్ ఫ్యాటీ యాసిడ్స్, లినోleic acid, linolenic acid, right? So these are basically present in many of your oils. So this lipid attached to a sophorose is called a sophorolipid because this sophorolipid has a functional group that is dispersible or soluble in water. We can make nanoparticles which are soluble in water. This is a nanoparticle soluble in water, right? Or dispersible in water. And obviously this can be used for antibiotic applications, lot of other applications. I don't want you to go through the application, but understand how to design the nanomaterial. Because we wanted to design a nanomaterial for a bio application, which means that the nanomaterial has to be dispersed in water, we had to create this molecule, right? Otherwise these nanoparticles would not have been dispersible in water. So that design is extremely important. Having this particular group at the end part of the molecule is extremely important. Now we have to create functional drugs. Let everyone చెప్పండి, ఎంత పెళ్లి గురించి చెప్పారు, ఎవరికి పిల్లలు చెప్పండి. Okay. So okay. So somebody, thank you. We would just okay, don't take it too seriously. I hope bite kalangane uske kotte kada, right? Okay. Adu nenu aalochinchanu, nenu idea ichanu basically, right? So you can see that, like, so basically this is again a wedding that is happening in a crazy manner, right? So iddaru pai nunchi kindaku dookutu, right? చావబోతున్నారు అనుకుంటున్నాం బేసికల్గా. పెళ్ళో చావో తెలియదు, రైట్? ఓకే, బేసికలీ సో దే ఆర్ డూయింగ్ దట్. సో వాళ్ళిద్దరు చేస్తున్నారు, వీ డోంట్ కేర్, రైట్? పాప ఈ మనిషి చూడండి, ఈజ్ రీడింగ్ ఏ బైబిల్, రైట్? వాళ్ళిద్దరి కోసం, రైట్? ఓకే, వీళ్ళిద్దరికి ఏముందో తెలియదు కానీ ఈ వరకు చాలా ప్రేమ అని పరిస్థితి, రైట్? సో బట్ దే ఆర్ వేరింగ్ దిస్ అండ్ అడిషనల్, రైట్? Apart from the wedding gown or whatever dress they are wearing, they are putting another dress. So can you think of additional dresses to the nanoparticle? Another layer onto the nanoparticle. So what we have done in our group is basically to create a monolayer protection and a charge on the surface. Both. నేను ఇంతకుముందు రెండు చెప్పాను. ఒకటి charged protection, which is colloidal dispersion, like milk. The other one is a monolayer protection. Can be combined these two, right? So we use a molecule called K.B.N gum. This is a food additive, right? It is an FDA approved or drug controller approved. So మనం తినచ్చు, right? So we wanted to use this molecule as a protection on the nanoparticle because it has a charge, a carboxylate group and a long chain polymer, right? So it can protect and also expose a charge. Once the charge is exposed, what we have done is put a molecule called doxorubicin hydrochloride. It's a cancer drug, highly potent cancer drug. This could take some side effects, right? So we wanted to reduce the dosage of this drug, right? So what we did is we put this drug molecule, instead of putting it everywhere, we put only few molecules of drug on the surface of a nanoparticle. And then we delivered it to brain tumor cell lines. Brain tumor. The reason is that one of the problems of brain tumor is there is something called blood-brain barrier. BBB is called, right? So many drugs are filtered by this blood-brain barrier. There is a barrier, blood-brain barrier, right? So blood is not allowed to go into that beyond that barrier. So how to cheat that? Sugar apparently can be taken in. Sugar is allowed to go in. The alkaline sweet and the just not. My brain could likes it, right? So that's why it takes it, right? So basically we thought because of the sugar moiety, because these are all carbohydrates, maybe this K.B.N gum is taken up, and along with that K.B.N gum, because that is present on the nanoparticle surface in huge quantities, all these triangles are K.B.N gum, and these small dots like this are doxorubicin hydrochloride. Maybe along with the K.B.N gum and the nanoparticle, the drug also goes in. And indeed it proved to be right. So we have seen that the K.B.N gum loaded nanoparticles are taken up by the brain tumor cell lines, and along with that doxorubicin was delivered and the brain tumor cell lines got killed. Right? So this is another work that we did. And then the final slide really for this. After that, 2-3 slides on careers, because I was told that I need to talk on careers. After that I will stop, right? How many of you South North India can say you must be. Can anybody recognize who is that guy? I will play. Good guess. చాలా తెలుగు పాటలు పాడాడు. ఏ పాడాడు అని అడగండి. ఏం జరుగుతుందో ఒకసారి నోటీస్ చేయండి. ఆయన ఆన్సర్ చెప్పారు, ఒకసారి తప్పని పట్టడానికి. ఆన్సర్ చెప్పండి. సోను నిగమ్ ఈజ్ నన్ అదర్ దాన్ సోను నిగమ్, రైట్? సోను నిగమ్ ఒక ప్లాట్ఫామ్ మీద కూర్చుని పాపం పాట పాడుతున్నాడు. ఎవడు పట్టుకోవాలి, రూపాయి కూడా వేద, రైట్? ద సేమ్ ఈవినింగ్ దట్ సేమ్ సోను నిగమ్ సెడ్ దట్ ఐఎమ్ సింగింగ్ ఇన్ ఎన్ ఆర్కెస్ట్రా, రైట్? అందరం పరిగెత్తుకెళ్ళి 1000 రూపాయలు టికెట్ కొనుక్కొని, రైట్? వాడు పేమెంట్ కూర్చొని ₹1 వేయరా బాబు అంటే నో, రైట్? అదే సోను నిగమ్ నేను సోను నిగమ్ అని చెప్తే 1000 రూపాయలైనా ఓకే, రైట్? సో this is the effect of disguising, right? So maru vesham antaru kada manam, disguise, we can make a disguise and then fool people. This is an experiment that was actually done in Bombay. This is actually an original experiment was done in New York also by another famous violinist. He was standing in New York subway playing violin, nobody cared, but the same evening in Broadway somewhere he was playing, everybody is paying $500 or something like that, went to his orchestra, right? That is our nature. ఎందుకంటే నువ్వు ఎక్కడికి వెళ్ళావురా, ఎక్కడి దగ్గరికి వెళ్ళారంటావు పాట వినడానికి. సో మనూడిగా దగ్గరికి వెళ్ళాలని చెప్పాలి కదా, రైట్? సో దట్ ఇస్ అవర్ నేచర్. ఎనీవే, డోంట్ వరీ. సో వాట్ వీ థాట్ ఈస్, కెన్ వి ఫూల్ ద క్యాన్సర్ సెల్స్? సో వీ వాంటెడ్ టు అండర్స్టాండ్ వాట్ ఇస్ క్యాన్సర్. వాట్ ఇస్ క్యాన్సర్? సింపుల్ లాంగ్వేజ్ లో అన్డివైడెడ్ సెల్, రైట్? అన్కంట్రోల్డ్ డివిజన్ ఆఫ్ సెల్స్ ఇస్ కాల్డ్ క్యాన్సర్. నాకు బయాలజీ పెద్దగా రాదు, నేను 10th లో మానేశాను, రైట్? దిస్ ఇస్ ద సింపుల్ డెఫినేషన్. నా దగ్గర బయాలజీ వాళ్ళు ఇక్కడ సిబిజెడ్ బిఎస్సి, రైజ్ యువర్ హ్యాండ్స్, రెండు చేతులు. నిజంగా ఐ డిడ్ నాట్ నో బయాలజీ, ఐ ఫీల్ రియలీ బ్యాడ్ అబౌట్ ఇట్. ఈజ్ మై డెఫినేషన్ ఓకే? అన్కంట్రోల్డ్ డివిజన్ ఆఫ్ సెల్స్, రైట్, ఈజ్ క్యాన్సర్, రైట్? సో దట్ మీన్స్ ఇట్ ఈస్ గ్రోయింగ్ వెరీ ఫాస్ట్. When something is growing very fast, what does it require? When somebody is growing very fast, what it is required? It requires more food, right? Simple. So we thought that can we provide the nanoparticle with some food? Sorry, not the nanoparticle, the cancer cells with some food. What is food for cells? Protein. So what we thought is, can we load the nanoparticles with a protein? So that if I feed them to, like in the video you said, normal cell, cancer cell. He showed the video comparison. A cancer cell is taking more food as compared to a normal cell. Right? You know, బలవంతుడు బలహీనుడు పక్కన ఉంటే ఫుడ్ ఎవరికి దొరుకుతుంది? Right? Unless we donate చేస్తే తగ్గుతుంది. Right? Okay, so basically that's what we thought of creating. So we created nanoparticles capped by a protein molecule called bovine serum albumin or human serum albumin. Albumins are proteins, right? These are taken up by the cells, right? So what we did is, apart from the protein, we also loaded drug. This drug was not seen; it was hidden. What was seen was the protein. So we fed these nanoparticles to two types of cells. One are called NIH53, which are called fibroblast cell lines, normal cell lines, right? The other one is LN229, which is a glioma cell line, right? So brain tumor cell line. So these cells and these cells, both of them same time, the nanoparticles with the coating of protein was fed, right? Protein coated nanoparticles along with the drug molecule was fed to both the cells. After 4 hours, what we have seen is, I don't know how clear it is, you can see that there is not really a clear red dot anywhere here. These particles, these fibroblast cells are not taking the nanoparticles as fast. In the same 4-hour window, you can show it as all red dots. It is taking more nanoparticles along with the protein. Otherwise, nanoparticles are the same. Right? Only the cell line is different. Same nanoparticles are fed to both the cell lines. One of them are taking more, one of them are taking less. Because this is a cancerous cell line, this is a normal cell line. Right? So with this, we could prove that indeed it can be killed, etc., etc. So more or less, this is what I wanted to tell you. You can actually create functional nanomaterials. These are functional nanomaterials which can be used either for printed electronic applications, or drug delivery applications, or defense applications. Defense applications గురించి వాళ్ళు మాట్లాడతారు. దాని గురించి అంటే వేరే డిసైడ్ కావాలి. You cannot say that I made a nanomaterial, use it for defense. ఇలా చేయలేం. It is not a currency note. You have to design. For an application, a material has to be designed. Like a tailor designs a dress for an occasion. Right? You need to create a design, make the nanoparticle suitable for that application and make it functional. మనం ఎలాగైతే ఫంక్షన్ కోసం ఎలాగ డ్రెస్ వేసుకుంటామో nanoparticle has to be made functional, and only then you can use it for a set application, for a desired application. That's what I wanted to show you. So, right, and all that is done. Right, last few minutes, career planning. This is what I was told. Right, career planning. This is preaching laga untundi, konచెం movie story laga untundi. This is okay, right? So career planning anagane manandariki vayachu, right? What is career? Future ఏంటి? Right? And once upon a time I was also like you. Right? It is not different, nothing different. We 20, 30 years ఏం పెద్ద మార్పు రాలేదు. Right? It is the same thing. Right? Do I have to go to science? Right? Do I have to make, basically, marriage, house, car, whatever, job, business, right? A lot of things. So, teacher says, be a doctor. Parent says, go for engineering. Friend says, join for some commerce. Right? Neighbor says, do MBA. ప్రతి వాడు సలహాలు ఇచ్చేవాడు. లైక్ నేను కొన్ని పదాలు వాడకు, రైట్? రోడ్డు మీద పెట్టి అడ్డమైన వాడు సలహాలు ఇచ్చేవాడు, రైట్? ప్రతి వాడు వచ్చి సలహాలు ఇచ్చేవాడు. ఏం చేస్తున్నావు అమ్మా? వాట్ నెక్స్ట్? ఏదో మూవీలో ఉంది, వాట్ నెక్స్ట్? రైట్? ఏదో చేస్తున్నాను, రైట్? So this is what is extremely important. Like you need to say that I want to do what I want to do. I don't want to do what you want me to do. Right? It is extremely important. First of all, this is extremely important. Right? Okay. So manantaram career anangane asalu ikkada unna vallaki prati vallaki unna oka alojana I want to be unique. Right? ఎవరైనా గొర్రెల మందలో గొర్రెలాగా ఉన్నా ఉంటారు ఇక్కడ ఎవరైనా కానీ అలాంటి ఒకసారి చేసేదంటే బయట. Right? ఎవరు అనుకో ప్రతి వాడు we want to be unique among the different people. Right? But when it comes to career, right? మనందరం ఏం చేస్తాం? ఒకడు ఎవడో పరిగెడతాడు, వాడారు కాబట్టి. Right? Okay, this is the problem. We want to be unique, but we are scared. Right? ఎవడో ఏదో చేస్తున్నాడు, అమ్మో అది చేస్తే మంచిదేమో సరే. Right? If you are unique, there is definitely a career for you. Right? If you are one among many, there is no career for you. Please understand this very, very clear. Right? నేను మీకు ఒక preaching లాగా అనిపిస్తే, ప్రవచనం లాగా అనిపిస్తే కానీ this is true. Right? What we are seeing today is basically copycats, what we call it. Xerox copies. Right? ఒకళ్ళ తర్వాత ఒకళ్ళు. ఒక్కోసారి సారీ ఇలా చెప్తున్నాను ఏమనుకోకండి, మీ దగ్గర నుంచి వచ్చి ఈమెయిల్స్ కూడా సేమ్ ఉంటాయి. ఒకడు పంపిస్తాడు, వరుసగా వస్తాయి అదే కాలేజ్ నుంచి టక్ 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 టక్. Right? Sir, I have seen your paper, I want to do a project internship with you. Respected sir, regards. ఆ regards లో D ముందర R వెనకాల ఉంటుంది. అదే అందరి దగ్గర నుంచి. Right? This is the problem. Please be unique first of all. Right? And for that, what is important? What is lacking? Right? What is lacking, I will say, is clarity, courage, and curiosity. Right? Why this one is not E is equal to MC square? This C cube is important. Why? What do I mean by clarity? And what do I mean by courage? And what do you mean by curiosity? First of all, clarity. ఏం చేయాలనుకుంటున్నారు? జాబ్ చేయాలనుకుంటున్నారా? బిజినెస్ చేయాలనుకుంటున్నారా? ఒక కొత్త వెంచర్ స్టార్ట్ చేయాలనుకుంటున్నారా? యూ నీడ్ టు హ్యావ్ ఎ క్లారిటీ. యూ నీడ్ టు హ్యావ్. మీ అమ్మా నాన్న, మీ పేరెంట్స్, మీ ఫ్రెండ్స్, వీళ్ళ కాదు, మీకు క్లారిటీ ఉండాలి. ఓకే, లెట్ మీ ఎక్స్ప్లెయిన్ టు యూ దట్. ఓకే, సో ఇవాళ కనుక ఇండస్ట్రీ వైజ్ చూసుకుంటే జాబ్ మార్కెట్ ఎక్కడ ఎక్కువ ఉందంటే ఫుడ్ చైన్ ఇండస్ట్రీ. ఈ స్విగ్గీలు, జొమాటోలు, వాట్ ఎవర్ ఇట్ ఈస్, one of the huge market, in fact one of the best market. I tell you, this market research నేనేమి విట్టగలను కట్టుగలను చెప్పట్లేదు. రైట్, క్యాటరింగ్ పెట్టుకుంటే బెస్ట్. ఫ్రాంక్లీ రైట్, ఇవాళ క్యాటరింగ్ బిజినెస్ అంత బెస్ట్ ఇంకోట్లేదు. వండడం మర్చిపోయాం అందరం కదా. రైట్, సో బేసికలీ వాట్ డూ యూ వాంట్ టు డూ? యూ నీడ్ టు హ్యావ్ ఎ క్లారిటీ. అండ్ దెన్ క్యాటరింగ్ ఇండస్ట్రీ చెప్పిన పెట్టుకున్న వాడు వెజ్ కార్లో తింటున్నారు, నేను ఇంకా మాట్లాడడం. రైట్, యూ నీడ్ to have a clarity. Please have that clarity. And I want to show you one example. And this is again, మీరు అందరి దగ్గర గూగుల్స్ ఉన్నాయి, మీ అందరి దగ్గర మొబైల్ ఫోన్స్ ఉన్నాయి, కావాలంటే వెళ్ళి సెర్చ్ చేసుకోండి. I don't want to fool you saying that this is what you need to do, but you need to decide what you need to do. Right? So do you know who is the person who is having the largest number of luxury cars in Bangalore? The largest number of luxury cars in Bangalore, including the Rolls Royce. 120 luxury cars. ఎవరై ఉంటారు? ఒక చీఫ్ మినిస్టర్ శివరాజ్ కుమార్ కదా, ఎవరు పునీత్ రాజ్ కుమారా, లేకపోతే వాట్ ఎవర్. హూ కెన్ దట్, హూ ఇస్ దట్ పర్సన్? కెన్ బి ఎనీ గెస్ ప్లీజ్? డిసైడ్. లగ్జరీ కార్ కావాలనుకుంటే ఇది కూడా చేయొచ్చు కదా. ఇదే తప్పు చెప్పాలి, నేను దాన్ని డిగ్రేడ్ చేయట్లేదు. నెవర్ ఎవర్ ఐ విల్ డూ దట్. ఈజ్ ఎ గ్రేట్ పర్సన్, డెఫినెట్లీ ఐ రెస్పెక్ట్. యూ డిసైడ్. రైట్, సో మనకి చాలా క్లారిటీ విషయంలో చాలా ప్రాబ్లమ్స్ ఉన్నాయి. రైట్, ఫస్ట్ ఆఫ్ ఆల్ హ్యావ్ క్లారిటీ. ఇఫ్ యూ వాంట్ టు ఎర్న్ మనీ, స్టార్ట్ ఎర్నింగ్ మనీ. రైట్, ఇక్కడ కూర్చుని నా క్లాస్ వినడం కూడా బేసిక్. రైట్, గో స్టార్ట్ డూయింగ్ దిస్ and money. Right? Why not? Like 120 luxury cars unte నేను కూడా సాధారణంగా తప్పే ఉంది. He is doing a respectable job and earning money, and he is owning 120 luxury cars. Right? What? It's not easy. Not at all easy. Right? So have clarity. Red example is like catering business, right? In this business, right? It's not easy at all. No way I am degrading any job. Right? So please have clarity what you want to do. మనందరికీ ఈ ప్రాబ్లం, బిగ్గెస్ట్ ప్రాబ్లం. రైట్, ప్లీజ్ అండర్స్టాండ్ దట్. ఓకే, నెక్స్ట్ కరేజ్. రైట్, వీళ్ళందరినీ మీరు చాలా మంది గుర్తుపట్టారు. రైట్, ఇండియాస్ టాప్ CEOs, ఆల్ CEOs of top companies are Indians. మనం చాలా ప్రౌడ్గా ఫీల్ అవుతాం. ఐఎమ్ ప్రౌడ్, నో డౌట్ అబౌట్ ఇట్, బట్ ఐ ఆల్సో హ్యావ్ ఎ ప్రాబ్లమ్ విత్ దట్. రైట్, వాట్ ఇస్ ద ప్రాబ్లమ్? There are some people, I don't want to name, it is not appropriate for me, one failed in this quarter, I did not take their permission. But who are they? They are the Microsoft CEO, he is B in India, MS in US, MBA in US, Google CEO, BTech in India, MS in US, MBA in US, Twitter CEO, who was sacked. Right? ఒక కొత్త ఓనర్ వచ్చాడు CEO Twitter. వస్తూనే మనం ఒకటి రాసి పెడతాడు అంతే. Right? Okay, so right, so you can see that these are BTech in India, PhD in USA. I said we are proud of them, but we are also having a problem with them. The reason is that who is owning these companies? These are all employees. Which దాంట్లో పనిచేసే ఉద్యోగులు మాత్రమే. Right? Who is owning the companies and what are their qualifications? Have you ever wondered? Who is the owner of Microsoft? I can take their names. Who is the owner of Microsoft? Owner of Microsoft. Who started Microsoft? Bill Gates. What is his qualification? వీళ్ళ క్వాలిఫికేషన్స్ ఇక్కడ చూస్తున్నారు కదా. What is his qualification? College dropout. What is Google founder? PhD discontinued. నేను PhD చేసి ఇలా ఉన్నా. కంప్లీట్ చేసి వాళ్ళు డిస్కంటిన్యూ చేసి గూగుల్ స్టార్ట్ చేస్తారు. But have courage. It takes huge amount of courage, which I also did not have. Like మీకు ఒక గొప్ప ఐడియా వస్తే, గొప్ప ఆలోచన వస్తే, by all means you have to take that risk. మనం ఇండియన్స్ పెద్ద ప్రాబ్లం ಇದೆ. రిస్క్ వద్దు, మనకి జాబ్ కావాలి, వాళ్ళ వందల మంది బయటకు పంపించేస్తారు, మళ్ళీ భయం. రైట్? సో జాబ్ క్రియేటర్స్కి ప్రాబ్లం ఉండదు కదా, జాబ్ సీకర్స్ ఎప్పుడు ప్రాబ్లమే ఉంటుంది, జాబ్ క్రియేటర్స్కి ప్రాబ్లం ఉంటుంది. లెట్ us be job creators. Right? So whatever it is, let us drop curiosity. This is the biggest problem right now we have. We don't have curiosity. ఏం జరుగుతుందో అనవసరం, ఎందుకు జరుగుతుందో అసలు అనవసరం. బట్ ఐఎమ్ సారీ, ఇది మనకే అని చెప్తున్నాను, నన్ను కూడా యాడ్ చేసుకుంటున్నాను, మిమ్మల్ని ఒక్కరిని అనట్లేదు. ఇది జనరల్ ప్రాబ్లం మనకి. ఏదో హూ కేర్స్, సాయంత్రానికి ఎవడో వచ్చి ఒక డ్యాన్స్ చేస్తాను, వాటి చూసేస్తాం వచ్చి. Right? So curiosity is extremely important, right? So I will show you one example with curiosity, right? There's a beautiful movie called Croods. It is the animated movie.
I will hear the story of Crispy Bear. A long time ago, this little bear was alive, but she listened to her father, so she was happy. But Crispy had one terrible problem. She was filled with curiosity. Yes,
He was curious.
one day she saw something new and died.
Just like that?
Yes.
Same ending as every day.
We never had the chance to explore the outside world. But what we didn't know was that our world was about to change.
Come down! Into the cave! Go! Look out!
You really need to see this.
ఒక్కసారి ప్లే చేద్దాం, కొంచెం వాయిస్ This is a beautiful movie. నాకు చిన్న పిల్లలు అంటే కార్టూన్ మూవీస్ అంటే చాలా ఇష్టం.
Crispy Bear. A long time ago, this little bear was alive, but she listened to her father, so she was happy. But Crispy had one terrible problem. She was filled with curiosity. Yes, and one day she saw something new and died.
Just like that?
Yes.
Same ending as every day.
We never had the chance to explore the outside world. But what we didn't know was that our world was about to change.
Hey, come down! Into the cave! Go! Look out!
You really need to see this.
So basically the story is this particular person, the father, always frightens the daughter, saying that there is a crispy bear which is filled with curiosity. And one day they are cavemen, they are in the caves, right? గోళ్ళు ఉండేవాళ్ళు మనుషులు వాళ్ళు. సో బయటికి వెళ్తే చచ్చిపోతాం. ఇదే రోజు చెప్తుంటాడు. ఆ అమ్మాయికి మనకి క్యూరియాసిటీ చాలా ఎక్కువ, రైట్? షీ గోస్ అవుట్, ఆఫ్ కోర్స్ ఇట్ ఇస్ ఫిల్డ్ విత్ డేంజర్స్, బట్ ది అవుట్కమ్ ఇస్ బ్యూటిఫుల్, రైట్? సో దిస్ ఇస్ ద స్టోరీ ఆఫ్ ద మూవీ. ట్రైలర్, రైట్? మన ఫస్ట్ ట్రైలర్ అయినా ఇది టీజర్, ఇదేమనాలి, వాట్ ఎవర్ ఇట్ ఇస్. ఓకే, సో దిస్ ఇస్ వాట్ ఇట్ ఈస్. దెర్ ఆర్ లైక్ హ్యూజ్ issues today in science, in technology, in society, and these can be solved only when you have scientific solutions today. There are no other solutions, right? There is only scientific solutions that are possible, and there is huge amount of investment that is going on in every field. I'm telling you, software may come, may go up, may go down. This material research, like pharmaceutical research, is not going to go down, right? Whether you are హ్యాపీగా ఉంటే ఎక్కువ తింటాం, జబ్బులు వస్తాయి. అన్హ్యాపీగా ఉంటే డిసప్పాయింటెడ్గా ఉంటాం, జబ్బులు వస్తాయి. ఏదైనా మందు తినాల్సి, రైట్? సో దిస్ ఇస్ నాట్ గోయింగ్ టు, ఐ యామ్ నాట్ సేయింగ్ దట్ యూ షుడ్ బి లైక్ దిస్ ఆర్ లైక్ దట్, రైట్? బట్ వాట్ ఎవర్ ఇట్ ఈస్, దిస్ పర్టికులర్ ఫీల్డ్ హ్యాస్ ఆల్వేస్ పాసిబిలిటీస్, రైట్? సో ప్లీజ్, ఇఫ్ అట్ ఆల్ మీకు ఇంట్రెస్ట్ ఉంటే, again, like, don't say that వీడెవడో చెప్పాడు కదా నాన్న తగ్గెత్తండి. Right? If you are interested, this is one of the fields. Science is a field that is good, lucrative, right, and gives you a lot of careers. Okay, so these are the different careers that are possible at different. I can even leave this slide with Bhaji Kumar or Krishnamani. You can see this class 12 Ayintradi, BSc Ayintradi. Of course, I am a chemist, so I know only about chemistry a little bit, but you can fill with other fields also. Right? You can do lot of programs, management, analytical research, IPR, right? Intellectual property, right? Protection. It's called IPR, patent protection. We need lot of people. We are very poor in filing patents in India. We don't have good patent lawyers, right? So we need to protect our intellectual property. We need huge amount of people in that field, right? So law from plus science. ఈ రెండు జరగా మీరు చేయగలిగితే you have beautiful cases, right? Again, don't go by my word. You have to have passion. నేను చేయగానే ప్రతి వాడు లా కెమిస్ట్రీ రెండు కలిపి చేసేసి ఇక్కడ నాకు జాబ్ రావట్లేదంటే, right? You need to have the passion. Obviously, passion is most important, right? So what can you get? You can get publications, you can get patents, you can get consultancy, sense of achievement, and most important, right? What do I get out of all these things? ఇక్కడ వచ్చి మాట్లాడి మామూలు వచ్చి మా పిల్లలతో మాట్లాడితే what do I get? Right? I get academic. Right? I get satisfaction. Right? I can tell you what I enjoy. Right? I enjoy my life. Right? Nobody నాకు ఎప్పుడు బాస్ లేడు. Right? I want to do, I do. Otherwise I will not. Right? This is the beauty. Right? You are paid for what you like to do, which other fields do. Gives you that satisfaction. Right? So if you have, right, one of the problems you have, right, you know, ఇలాంటి కాలేజీలు కానీ నేను కూడా ఇలాంటి కాలేజీకి వచ్చాను, అది ఎస్ఆర్ఆర్ కాలేజ్, ఎందుకంటే బస్ కాలేజ్, రైట్? ఐ హ్యావ్ నో ఫార్మ్స్ ఇన్ సేయింగ్ ఆ కాలేజ్కి కూడా లేకపోతే ఇదే మాట అయితే రైట్. సో ఏమీ ఫెసిలిటీస్ లేవు, బట్ వీ కేమ్ అవుట్ ఆఫ్ దట్ కాలేజ్, రైట్? సమ్ ఇంట్రెస్ట్ ఉంది. కెమిస్ట్రీ అంటే మంచి టీచర్స్ ఉంటారు, బ్యూటిఫుల్ కెమిస్ట్రీ టీచర్స్ we have, right? I hope your chemistry teachers also are as great as them and they are teaching you great. So one of the problems we all face is basically not having skill. What is that skill? We know the theory, but we don't know how to apply it practically. So again, there is huge amount of programs. All our laboratories are taking care, undertaking programs what are called SDPC, skill development programs, right? So if we small, very cheap karao, free karao, right? This is about for 5,000 rupees for 1 week, but we will give you hands-on training on UV visible, transmission electron microscope, all high-end equipment. Hands-on training. The one may double right? It's just to cover those expenses. 5,000 rupees for 1 week is not an expensive at all, right? I hope. So please use these opportunities. మా దగ్గరే కదా అన్ని చోట్ల ఉంది. ఐఐటీస్లో ఉన్నాయి, యూనివర్సిటీ ఆఫ్ హైదరాబాద్లో ఉంది, ఎన్సిఎల్లో ఉంది, సెన్స్లో ఉంది. I have some brochures belonging to the STPC program. Not only that, what we have done at SENS is that we have tied up with Rotary Club. The Rotary Bangalore have tied up with us. What they said is 2 of the needy students will provide them scholarships. Even that 5,000 is waived off. Evarikante I don't know. Right? You need to apply for that, and if you get it, we are not the deciding factor. Rotary Bangalore decides. So whenever there is an advertisement, I will send to Bhaji Kumar or somebody, please apply. మీకు కనుక స్కిల్ డెవలప్మెంట్ ఉంటే ఎలాగా హ్యాండ్స్ ఆన్ ఎక్స్పీరియన్స్ ఉందని మీరు చూపిస్తే ఆఫ్టర్ దిస్ ప్రోగ్రామ్ దెర్ ఇస్ అ సర్టిఫికేట్ గివెన్, రైట్? సో యూ ప్లీజ్ యూటిలైజ్ దిస్ ఆపర్చునిటీ, రైట్? ఇట్స్ నాట్ an advertisement, as I said, nothing comes out of this. We will probably spend more money on this than what we are earning, right? But still we need to do this. We understand that we need to do this, not just here, everywhere. It is true, right? BSc lo MSc lo manchi labs leave, we know that, right? Therefore we have started these programs everywhere, and government is supporting. We do get government support, right? So please utilize these opportunities. Also there are programs called Summer Research Fellowships, SRFP. The program is called SRFP, Summer Research Fellowship Program, both for the teachers as well as the students. It's a 2-year paid fellowship program. Meeku double darugutundi, but you have to write a proposal, right? And you have to choose a guide. So you contact them. Don't say that I want to do something. Em chestunnaru teliyadu. I don't know anything. That's what you should do, because we know that you don't know anything. And there is nothing wrong in that, saying that I do not know. Manandariki ado anni telisipoyinde cheppali, right? That is wrong. We want to learn, right? So manaki okkasari like I am from this college. Actually I am very eager to know. I am very enthusiastic to know. మాకు ఆపర్చునిటీ ఇవ్వండి అని ఒక ఈమెయిల్ రాస్తే నాలాంటి వాళ్ళందరూ పాజిటివ్గా రెస్పాండ్ డెఫినెట్ రైట్. ఏదో వచ్చేసింది అనుకుని కాపీ కొట్టి ఈమెయిల్ రాస్తే మటుకు రెస్పాండ్ డెఫినెట్. అండ్ వీ హ్యావ్ ఎనఫ్ ఎక్స్పీరియన్స్ హియర్ రైట్. సో దట్ వీ కెన్ సీ వాట్ ఈస్ కాపీడ్ ఈమెయిల్, వాట్ ఈస్ యువర్ ఒరిజినల్ ఈమెయిల్. మన ఇంగ్లీష్ ఎంతో మన ఎంతో అంతా నేను కూడా అక్కడి నుంచి వచ్చాను, ఎక్కడి నుంచి రాలేదు రైట్. మనకు తెలుసు కాబట్టి ఆ నిజాయితీ ఉండాలి ఈమెయిల్. ఆ నిజాయితీ చూడటం పెద్ద కష్టం కాదు. అది ఉంటే డెఫినెట్గా రెస్పాన్స్ వస్తుంది. సో అప్లై చేయండి. సమ్మర్ రీసెర్చ్ ఇంట్రెస్ట్ ఉన్న వాళ్ళు మాత్రమే, ఇంట్రెస్ట్ లేకపోతే డోంట్ వరీ రైట్. సమ్మర్ రీసెర్చ్ ఫెలోషిప్కి అప్లై చేయండి. రండి, ల్యాబ్లో ఏం జరుగుతుందో చూడండి, ఎక్సైట్ అవ్వండి. వీ హ్యావ్ ఫన్. రోజు ఫన్నే మాకు ల్యాబ్లో రైట్. వీ ఎంజాయ్. బోరింగ్ అయితే ఉంది రైట్. ఎవ్రీ డే ఫన్ కిక్ రైట్. కిక్ కొన్నిట్లోనే రాదు, చాలా వాటిలో వస్తుంది రైట్. ఓకే, యూ కెన్ హ్యావ్ కిక్ ఇన్ మెనీ థింగ్స్ రైట్. రవితేజ్ గారు చెప్పారు కదా కిక్ ఉండాలి బాబు అని రైట్. So kick, right? Basically for that enjoyment, for that satisfaction. If you want to do science, please do science, right? Okay, I think that's what I want to do. So if we have our clarity, courage and curiosity, right, then this is not very difficult to make our country a Vishwaguru, real Vishwaguru, right? That is what the dream of many of our Guru teachers is, right? So yeah, thank you. 4 o'clock.
K.B.N College. First of all, I extend my heartfelt thanks to Dr. B.N. Prasad Garu, in spite of his busy schedule, to come over here and share his valuable knowledge on nanoscience to us. We have learned a lot about the importance of nanoparticles and magic which is involved in nanoparticles, in nanostructures and applications of the nanomaterials in our daily life, like in the treatment of cancer cells, like that. And once again, I am very thankful to Dr. B.N. Prasad Garu for nourishing our students and for giving career guidance to our students. Now I would like to thank our college management to give us permission to conduct this program. I also thank our beloved principal sir, Dr. P. Narayana Garu, and vice principals, Sir P.R. Ramesh Garu and Dr. M.B.R. Garu for their support in organizing this program. Finally, I like to thank the Department of Computer Science for their technical support. Thank you one and all.